we're going to look at repeating decimals in this particular section. So before, the decimals either terminated, well, most of them would terminate, like 1/4 is 0.25, and you're done, right? But sometimes decimals repeat, and they'll get this repeating pattern. Sometimes the repeating block of numbers is just one number, like 0.222222222. Sometimes it's like 0.25252525. Sometimes the repeating block is 0.123 123 123. So that repeating block is called the repetend. I'll spell that out, repetend. Sometimes it has 1 digit, sometimes it has 2 digits, sometimes it has 12 digits. I mean, how do you know? So I'm going to kind of do some long division, and I'm going to tell you how you can figure out how long the repeating part might turn out to be. So we're going to start with 1/6. 1 divided by 6, so I'm going to do long division. If I'm going to do 1 divided by 6, I need to put a decimal, put my decimal up here for my quotient, and then I need to have a whole bunch of zeros because I don't know how big this repeating pattern is going to be. So you just have to start dividing to find out. If you have like a little handheld calculator like I use this one, it helps when you're doing this. So 6 does not divide into 1, but 6 divides into 10. It goes in there once. 1 times 6 is 6. And when you subtract, you get a remainder of 4. And then I'm going to carry down my 0. How many times does 6 go into 40? It goes in there 6 times. 6 times 6 is 36. And what do you know? We get a remainder of 4 again, which means then I would carry down a 0. And I get another 40. And if I divide again, I'm going to get another 6, and then a 36, and then a 4, and then I'm going to carry down. Do you see how repetitive this gets? Like, why are you going to keep going? The same thing's going to keep happening. You're going to keep getting 6s and 6s and 6s. Okay, so the way that we write that as a repeating decimal is like that. 0.1, and we just put the repeating bar on top of the 6 because the 6 is the thing that repeats. It's 0.16666666666, etc., etc., etc. Okay. Now let's try 2 11ths and see what happens. And I'm going to explain to you about the repeating pattern. So this is 2 divided by 11. So 2 divided by 11, put in a decimal and a whole bunch of zeros. 11 does not divide into 2, but it does divide into 20. It goes in there 1 time. 1 times 11 is 11. And then you subtract, you're going to get a remainder of 9, and then you're going to carry down a 0. How many times does 11 go into 90? It goes in there 8 times. 8 times 11 is 88. That's going to be a remainder of 2. Carry down a 0. And now we're back to 11 divided into 20. And I feel like we did that before. So 11 divides into 20 once. If I subtract, I get 9. And then when I carry down my 0, I'm going to get a 9. I feel like I've done 90 before. So do you see, we've already latched on to the fact that, yeah, it's going to go in there 8 times, etc., 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 right? So this repeating pattern, it actually is a double block there. The repetend has 2 numbers. It's 0.181818181818. Sometimes the repeating block has 3 or 4 numbers in it. So here's more information about repeating decimals than you probably ever wanted to know. But let's look at this little notes that I have here. When you're dividing by 6, like when we divided by 6 up here, the only non-zero remainders you could get would be a 1, a remainder of 1, a remainder of 2, 3, 4, or 5. You can't get a remainder of 6 because if you get a remainder of 6, that means the 6 could divide in more. So you didn't divide it enough times. So you should only get remainders that are less than this divisor, 6. As soon as a remainder reoccurs, as soon as you see a duplicate remainder, you've latched onto the repeating pattern. As soon as that happens. So if there's only 5 remainders you could get, that means that this repeating block can't contain more than 5 digits. It just can't. So if you're dividing by 6, the repetend, the repeating block, will not have more than 5 digits. It turned out that it's only a 1 block. It's a 1, 6, 6, 6, 6, 6, 6, 6, only had 1. But if we look back at the work we did, the first division we did, we got a remainder of 4. And then when we divide it again, right there, we got a repeated remainder of 4. And at that point, we could see that we were going to get a repeating pattern. And we divided again, there we got it again. We got the same 4. So the second you see it repeat, you know that you've got your pattern. Let's look at what happens over here. Now, if we're dividing by 6, we knew that the repeating block wouldn't have more than 5 digits. If you're dividing by 8, the repetend won't have more than 7 digits. You see the pattern. If you're dividing by 13, the repetend won't have more than 12 digits. There's definitely a pattern here. So if we're dividing by 11, we know the repetend will not have more than 10 digits. That doesn't really make me feel better. Like, that's still a lot of places. But at least I know it wouldn't have more than 10. Because by the time you repeat a remainder, that's where the pattern occurs. So let's see it here. Our first remainder that we got was a 9. And then the next remainder I got was a 2. See, those are both less than 11. And then right there, I got the repeated remainder. And right there is where I knew that I had the repeating pattern. So 1, 8, 1, 8, 1, 8, 1, 8. So you don't actually have to do long division until you want to die. You just do long division until you get a repeated remainder, and then you know you can stop. So the repeating block of digits, like I said up at the top, is called the repetend. So if you see that word anywhere, you'll know what it is. But there are some things, some kind of easy to memorize repeating patterns that show up quite a bit. So 1/9 is one of those. Like this, you might just add it to your little toolbox of tricks here, because 1/9 is a really easy repeating decimal to remember. So if we want to take 1 and we want to divide it by 9, I've got to put a decimal and a bunch of zeros, right? There's my decimal. So does 9 divide into 1? No, but 9 divides into 10, goes in there once. 1 times 9 is 9. Get a 1, carry down to 10. 9 divides into 10 once, and do you see what's going to happen here? There's your repeated remainder. As soon as you get a repeated remainder, we know that we're done. So there is one little number that repeats. 1/9 is 0.111111111. So what do you think 2/9 is? Take a guess without doing a lot of crazy math, without doing long division. If 1/9 is 0.1 repeating, guess what 2/9 is? Well, if you said 0.2 repeating, you would be correct. And guess what 3/9 is? And guess what 7/9 is? There's the pattern. So that's one that you might just throw into like a quick memorization if you've got room in your brain that you can spare. You do. So that you don't have to do any math on these. It's super, super simple, but it's just got one repeating block. The repetend is only 1 digit long. But that's why all of those kind of have some patterns.